Hi, I'm Granny, and we're going down the rabbit hole of the light spectrum and stars. I am not a scientist, I'm just a curious granny. So, in the last episode, we learned that we don't all see the same colors, that we were introduced also to the word spectroscopy, and spectroscopy helps us understand stars better. It is the study of the interaction of light and matter, and it helps us understand wavelengths and frequency. Another way to describe or explain spectroscopy is that it is a branch of science concerned with the investigation and measurement of spectrum, produced when matter interacts or emits electromagnetic radiation. I know that seems a little complicated, but it is really important for us to understand that to understand stars. So also understand that there is an important difference between frequency and wavelengths. Frequency shows the number of wave oscillations in a given time. So wavelength specifies the difference between specific points on a wave. There is a low frequency signal and a high frequency signal, and you need to study that chart to understand that it is the central theory of spectroscopy is that light is made of different wavelengths. Different colors have different wavelengths, and that each wavelength corresponds to a different frequency. The importance of spectroscopy is centered around the fact that every different element on the periodic table has a unique light spectrum described by the frequency of light it emits or absorbs. So we were all taught that if it's a hot day, don't wear black because the black absorbs heat, where white emits it, it bounces off. So most elements on the table, on the periodic table, on the left side are the metals and on the right side are gases. Now, the first periodic table generally accepted was created by a Russian chemist called Dmitry Mendeleev in 1869. In 1913, a Dutch physicist by the name of Antonius van der Broek proposed that the atomic number, because we got to the space in science, that we could anticipate the atomic number on a particular element, and that the nuclear charge should be determined. So the atomic number or nuclear charge should determine the placement of the element on the periodic table. So there was a readjustment. For us to understand spectroscopy and stars, we have to understand the atomic table. The atomic number is the number of proteins in the nucleus of an atom, which determines the chemical properties of an element and its place on the periodic table. Now, why are we even talking about this? Well, it's because the stars. We have to understand the periodic table to understand the stars that are in the heavens. All right, so the periodic table is a table of chemical elements arranged in a logical order of their atomic number, usually in rows, so that the elements with similar atomic structures are categorized closer together, and the chemical properties are in the vertical columns. So originally, the stars were classified by the colors that we see. So they were organized by white, yellow, red, and deep red. Later, they were further defined by variations of white. Remember when you go to the hardware store and you see all those different colors? So there's variations of yellow, white, so on. So then they were structured that way. But spectroscopy provided the technology to understand what those colors were and what the elements that were in those particular stars. But not only the stars, it helped us understand the planets within our solar system. All right, so to further understand spectroscopy, we need to understand that there is a difference between how heat is measured and temperature is measured. Heat and temperature are two different but related ideas. Heat is the form of energy that transfers from a hot body to a cold body, like stars or people. A cold person is standing over here, and then a warmer body comes over and helps warm up the cold body. All right, so temperature is the measure of the degree of hotness or coldness of the body. Not necessary. So the temperature is a measure of kinetic energy of the atoms and molecules in the system. A Kelvin is a measurement of temperature named after the Belfast-born and University of Glasgow-based engineer and physicist William Thomson, who was the first Baron of Kelvin. He lived from 1824 to 1907. So the Kelvin scale is an absolute thermodynamic temperature scale, meaning it uses absolute zero as its 0 point in Celsius. So joule is a measurement of heat. The term joule comes from the English physicist James Prescott Joule. In electrical terms, it's a way to understand electricity, i.e., the energy released in 1 second by a current. Imagine that every photograph you have ever seen of the universe, scientists have used spectroscopy, their knowledge of spectroscopy, and their knowledge of temperature and heat, joules and kelvins. Because the temperature that the photographs and our telescopes are documenting gives our scientists an understanding of the chemical properties of that particular star. For instance, we mentioned earlier that infrared is one of the chemicals released from the sun that has a direct impact on our Earth. We can't see it, but it's one of those things that are critical to our environment here on the Earth. So infrared is an electromagnetic radiation with wavelengths longer than those visible on the light spectrum to our eyes. And generally the wavelengths are from 1 millimeter to 700 nanometers. So remember last time it was 380 nanometers is in the spectrum that our eyes can see. So the balance between absorbed and emitted infrared radiation has an important impact on the Earth's climate. So put that kind of back in the back of your mind because we'll come back to that. I want you to take the time to do your own investigating on some of the pictures from the Hubble telescope. It's called the Hubble Extreme Deep Field Telescope. And some of the pictures it has sent back to Earth are mind-blowing. They're amazing. The colors, and again, the cameras used in these big telescopes see a variety of colors that our eyes can't see, but some of those are captured in photographs. So if you were to look at a picture of whatever the telescope is showing you, and a photograph of that. The photograph will reveal more to our eyes than our eyes at the moment. That's kind of hard to. Anyway, so of these telescopes, they use five main instruments to observe the ultraviolet, the visible, and near infrared regions of the electromagnetic spectrum. It's really hard to understand the concept that I can take a picture and that picture will show my eyes more than my eyes could have seen. But it's true. So most cameras pick up with telescopes parts of the light spectrum that our eyes don't see. Carl Sagan was a very famous astronomer, and he was known to say that there were billions and billions of galaxies, but the Hubble telescope has increased that number or that estimate to 20 trillion. No longer billions. And it was the Hubble telescope that gave us that knowledge. So that estimate also updated the estimate that is the number of stars in the Milky Way galaxy, because the Earth is located within the Milky Way galaxy. I want you to go to science.nasa.gov and look up the Butterfly Nebula. It is incredible. A nebula is a cloud of gas and dust, debris, think of volcanoes, in outer space, visible in the night sky, either as an indistinct bright patch, or in some cases, it's a dark silhouette against other luminous material. For instance, if there's a bright something behind it, and then you can kind of see the difference between what the brightness is back here and the dark patch. But nebulas are fascinating. I want you to go to that website because you can actually see recent pictures of Saturn and Mars. And by understanding spectroscopy, they're discovering information of the composition of stars and planets within our universe, our solar system, but also those far, far away in other galaxies. Remember when we talked about in volcanoes, Lake Nyos, erupting that gas that no one could see, but it killed thousands of people and animals? Well, it is important to know what you can and cannot see. I want you to join me again when Granny goes down the rabbit hole of black holes. Can you see a black hole? What is a black hole? I don't know. Please like and subscribe and share. Thank you for taking this time to be with me when I'm trying to understand stars better. Thanks.